This is site number 2. We generally come down here and there's 2 sites that we study every year since somewhere around 1995. The reason why this is a good site, on our side over here we have a couple houses that abut the stream, come right up to it. So anything that they're doing in their backyard is going to get carried right into the river. Right where I'm standing here, it's kind of a basin. Any of the runoff coming from the road up above is going to come right down in through here, be added right into the stream. We park up on Mammoth Road, and there's a bridge right there. So again, anything during any time of the year, sand, the cars going back and forth, all that's could be carried directly into the river also. And we have a road with a bunch of houses on both sides of us right behind us here too. So even though looking around here you can see that there's a nice forest, there's a lot of nice trees here, even though it looks like a nice place, there's a lot of man's got a lot of use right around here. This drains Derry, so it comes from Beaver Brook, runs right through the city of Derry. It goes right by the golf course that's out there, so there's a lot of stuff that's adding material to the water. Goes by the old landfill in Derry, goes right under 93. Also goes by a couple sand and gravel pits too, and a lot of different types of businesses. One of the reasons why we're here today is to take some samples, a bunch of different samples similar to what states do across the country. We're going to test it to see whether the water is healthy, not healthy, and then we're going to compare it to the data that we've had from the past. So now it's time to get our boots on. I got little feet too.
So that we can fill out information. One of the important things that we need to do every year is to make sure that we document the weather conditions in general, because you may find one year, for example, we had a hurricane several years ago, and we had a lot of rain, and we came out here, and it would look, as you look at the pictures today, you'll see that the brook seems to be quite gentle flowing. Yeah. If you had a hurricane come through or an inch of water, you would find that this nice quiet stream would then turn into a little bit of a torrential stream, and the conditions would be quite different. So it's very important that the daily weather conditions and just in general, what does the river look like when we go through it, is documented, so that if we see differences in the tests that we're doing, at least you can get an idea of what might be affecting the numbers that you're getting, in case you find something that's really different. So we'll be filling out this chart today, and along with it we'll be doing various tests, and these would have been the ones that you would have been doing, and some of these you will still do in the classroom. But we'll go through this, and as we get the information, we'll fill out the chart and we'll show you how it all goes together. By the time we're done today, we will not know the quality of the environment overall, because we have to go back and analyze it. But this is the information that's needed in order to determine what the health of the river overall is like. So we'll be doing each individual one, and we'll give you a little show of how each one is done.
Yeah, fill it up to that.
Okay. One particular test that we do, and this was actually brought up with the hurricane down in New Orleans, where they were indicating that the water had, I think it was 10 times the normal expectancy of what are called fecal coliforms. These are bacteria that come from the intestines of warm-blooded animals, and we will test for them here. And to have a high amount is not very good, because it indicates that there's a lot of solid waste coming from warm-blooded animals such as humans. It could be dogs, cats. It's an overall indicator. And all you do is you have a little paddle device, and we go out and we collect water up to the line here, and then you take the paddle, which has a little grid on the back, you put it in the water and you turn it upside down, and 30 seconds later this will have pulled materials up to it, and with that it would have collected some of the bacteria. You then take it out, shake it, dump the water out, put this back, and then this goes back into school, and we have an oven that basically matches the temperature of a human body. Because remember, these bacteria came from the intestines of warm-blooded animals, such as you. So we want to give them an environment where they can grow. There's already food on here, and after 24 hours we see what growth has occurred. And you can easily count the bacteria because of the grids. So it makes it very easy so that you can count how many are there. and that will determine if the water is okay in general, or if we find too many of them, that we have a concern about fecal matter getting in here. And that does not necessarily mean, for example, we have houses here, even though, like, for example, septic systems have fecal coliforms in them, it doesn't necessarily mean that it's coming directly from someone's septic system. A cat could have come along and pooped on the side of a path, or a raccoon. Any warm-blooded animal could have caused these to be in the water. But so we do expect probably to find some, but it's how many that's the important thing. And today, since it hasn't rained, we'll probably find a low level of them. But again, we'll do the test and we'll find out what that comes out in regards to its quality. But that's the fecal coliform count test that we're doing.
A demonstration. Check out the boots too. This is why we come to the river, so we can wear things like so. Waterproof, fantastic.
With the fecal coliform test, the little counter there, you have to put in the heat in the oven for 24 hours. This is a nitrate test. It's very simple, and as you can see, there's color codes on the outside. Nitrates can come from a variety of sources in the environment, and it has an impact on some of the nutrients for plant growth and things. But what you do with this is you dip this in the water. After 30 seconds, we compare the nitrite, the top one, and then after 60 seconds, you bring it up to the nitrates. And we're primarily looking here for the nitrites, but it's a very visual. Dip it in, and within 30 seconds, you have some information about the possibility of nitrites, which is a form of fertilizer. A lot of fertilizers have them in it. And again, it's okay to have nutrients in the environment, but depending upon how many you have, it will have an effect on the living organisms and plants in the stream, and that's what you're trying to monitor. Are there too many nutrients? Are there too few? And again, at the overall analysis, we'll find out how that means in the overall health of the stream.
You gonna synchronize?
Wait for the timer.
You can just dip them in and I'll tell you 30 seconds.
Leave it for 30 or you take it out?
You pick it up, yeah, you dip it, you pull it out. And 30 seconds, I'll take one. I'll look at the night. Right. Do not shake it. 30 seconds. Night test first.
All right, so we dipped it in. We compared it after 30 seconds, after a minute, and you can see that there's no nitrates, which is what we're actually looking for the most, and maybe a bit of nitrate, but not enough to even be a 1. So it's down maybe a little bit darker than what a 0 would be, but basically there's no nutrients, no nitrate nutrients being carried by the river, which means probably what's in there is being used by the plants right now, which is good.
Riverbed color: orange, yellow, brown, black, green, blue, green. From here, where we take a look, where it enters where the sun enters the stream, and you can see the bottom. What does the bottom look like?
Dark brown. Yeah, black. Brown.
Brown.
Dark brown.
Okay. Water appearance. As you're looking into it, is it clear, milk, muddy, scum, foam, oil sheen, or colored?
It's clear, but there's like a cloudiness to the top, at least when the sun's hitting it.
Mm-hmm.
It's not like some of the streams that you see that are clear right down to the bottom. Of course, once we start walking through it, it won't be clear at all.
Yeah.
But right now it's clear, but there's a little bit of cloudiness.
Clear with a little cloudiness?
A little bit of cloudiness.
Partly cloudy.
Dirty, but it looks parasite free.
Okay. Lobster dinner tonight. And this was one of your critters that you that actually goes towards evaluating the health of a river using the living things. There's a lot of critters in here that the state finds has no relationship to whether the water quality is good or bad, but the crayfish is one of the critters that adds to the points that go towards determining the quality of the river. So it's nice to see one of these guys. That's a pretty big one too. Chemical factor that we measure for the river is pH. And if any of you have ever washed your hair with soap that really wasn't made for washing your hair, you may have found a tingling sensation to your scalp where it itches a little bit, or it may cause you to get dandruff the next day. It's just not good for your head or your hair. And pH is a measure of water, which also has an effect on whether living things in the water, macroinvertebrates, can live here or not. And pH on the scale, we know number 7 is in between being very acid versus very base. And the state of New Hampshire Fish and Wildlife Department has allowed us to take some probes that they've given us, and all we do here, I'm going to take the probe and put it in the water, and we'll be able to indicate the pH of the water. There's other ways of testing it, but recently with the new technology, we find that with some probes, you just stick it in the water, and you can find that within a minute you have all the information that may have taken you several minutes to get the same information using chemical tests. So it saves a lot of time. So I'm just going to take this and stick it in the water, and we'll see what happens here. Little chubs out here, quite a few, about one flock of 6. And what we do is we just take it to the point where the number doesn't change that dramatically back and forth. And so now 7 is perfectly balanced, so for us to have a pH of about 7 is pretty good. Is moving back and forth. It seems to be moving back and forth between around a 6.32 and a 1, and at 16.9 degrees Celsius. So I'm going to write that down as 6.53, and then we just turn it off. And it's 16.8 degrees Celsius, and we write those two things down. And again, we don't know the meaning of that other than we know it's fairly close to being balanced, but when we do the overall analysis, we'll see how it fits into the overall health. But that looks like a pretty good reading.
Put it in the sun. We've got a water penny. It's hard to see. Let's see if you can see it. It's moving right now. It's right there. Looks like a little bit like a limpet if anybody knows marine bio. But remember, water pennies are some of the most sensitive. So this is a good sign for this water. But the key thing for all the students to remember is that you don't find them in a river that's somewhat polluted. It has to be pretty clean. It's pretty sensitive.
This is still pH, but what we're doing is, just in case, if anything, as with all technology, if it doesn't work, sometimes you need to go back to the old way of doing things, and what we're going to do is we took the pH using the digital monitor, and I just want to make sure that everything's okay, so we always do a double test, a backup, to make sure that everything's okay. So in case the technology is faulty, could have been set wrong incorrectly, whatever, or the battery could be dying, just to make sure we're going to do a visual test, and we'll see how this comes up, and then we'll compare the two. And if they match one another, we know we did okay. We move on to the next test. Okay. We just did the pH test with the visual, the color visual, and if we can look at the possible combinations, it has to match the same combination. And the big thing here is we're looking at the green here as being as an indicator We go to the other side above 7, we start getting into blues, and that doesn't fit. So we come here, and if we look at this green here, it's just a little bit lighter than this one. And we've been holding it a little bit longer than usual, but it looks a little bit lighter than that. So it's going to be, if we bring it over here, it's somewhere between a 6 and a 7 with the green matching. And when we use the digital pH meter, it ended up being 6.5 here, and then when we went out to the middle, it was around 6.8. So the visual here indicates that our pH meter is working and that we have a really good accurate number on that. And that's a way of just double checking. This is a real simple test that we don't do outside here, but we'll do back in the school. What we want to do is we're going to fill up the bottles with water, and today we'll be doing a dissolved oxygen test to find out how much dissolved oxygen is in the water. But we also want to find out how many living organisms are in the water that are in a sense of how much oxygen they use up over a period of time. And this is called BOD, and this is an indication of basically how much oxygen is being demanded over a period of time. And the state has just basically, and many other states have decided that we test the use of oxygen over a 5-day period. So how much oxygen disappears over 5 days because of the living things that are in the water using it up, just like you do to survive. You breathe in so much air and you use so much oxygen per day. This is an indication of how much oxygen is used up by living things. And when we bring this home, we'll put it in a dark place because we don't want any plants doing any photosynthesis. So by doing that, we know we're just measuring how much oxygen is used up by the living organisms in here. And how much is used up is an indicator of the health of the river also. So I'm going to take 5 samples, bring them all home, and we'll do a dissolved oxygen test on them 5 days from now.
Yeah, nice curve.
Another test that's important is the dissolved oxygen, and we do have a meter for that. And so we're going to take a digital reading of the water, and then we're going to do the old chemical testing. We have some new kits that we're going to try out to see how they do. And again, it's just like the pH. There's old ways of doing it and new ways, and we're doing them both to see how they measure up to one another. And this way too, in the classroom, since we're only using the digital ones for a short time, students might be doing the chemical testing versus using the digital technology, and that way they can learn how to do some of the old science to see how we appreciate how much time it may have taken in the old way to get information versus the new way with the digital.
This is the old way of doing it. We have a digital readout now that we're not sure how it's going to work because the state didn't quite get it set up for us this year. They kind of forgot about it, so we'll see. But the old way of doing it, we take the bottle, we need to get a sample halfway between the top and the bottom, somewhere where the river's coming through. So right here, this is basically where most of the stream flow is coming through. And the important part is to make sure that there's no bubbles in the bottle at all. There we go. Now we need to do some chemical tests on it to see how much dissolved oxygen is actually present in this water sample.
Gotta let out all the bubbles. Bubble free.
doing now is just double checking with the equipment too. We had a digital readout of the temperature, and I'm just taking the old-fashioned thermometer and double checking it so that we make sure that, again, technology is working properly. At every season, the water is a little different. Right now, the fall, with all the beautiful colors around here, and it's going to get even better, but you can notice there is certain debris in the water, the leaves, and stream. A lot of the food that comes in the stream is from above, so when you see this during the fall, this is what you may look at as a problem in your yard that you have to pick up. In a stream, it's very important because it's like the supermarket coming to you, and so to have this debris here is very important for keeping the critters alive because it's their food source before the wintertime gets in, and then we have ice and everything else here.
I've got precipitate.
Already?
Yeah.
You should.
Oh, we just did the first step.
Yeah, you should.
That means there's oxygen in the water.
Fantastic. That's good.
It means the fish that are in there are still alive. The ones we saw swimming around.
Good.
Alkaline, potassium, iodine. 1, 2, 3, 4, 5, 6, 7, 8. Ooh, that looks nice, huh? Nice and cloudy.
Okay, one other thing we want to test, in addition, we're going to be taking 2 samples back to the room. There are certain things that we can still monitor back in the classroom, for example, pH, nitrates. These are things, chemicals that aren't going to change over time, such as dissolved oxygen. You want to test for DO right away, and that's what everyone's testing right now for, is because once you bring water out of the place where it is, you can bias the result. You can lose oxygen, you can agitate it, you might put some back into it. So you don't want to do the DO, dissolved oxygen, back at the classroom several hours later. But there are some chemical tests you can still do. So what we do is we take a few extra bottles to bring back with us so that not all classes are here, so some kids might want to do some testing on their own. And that's how we can do that. But also with these bottles is that we will also determine total solids inside with the water. They say water is a universal solvent, and in it things can dissolve in it, but also it can carry materials that you can see. And with the cloudiness here, it's hard to tell, but what we will do is we'll take about half this water, bring it back, pour it into a beaker, and we will evaporate all the water from it in a beaker. And you can determine total solids by, once all the water's gone, is you subtract the mass of the beaker with whatever's left, and we determine how much total solids are actually in the water, both dissolved and floating through it that aren't dissolved. And that also is an indication, you need that to indicate the quality of the water. So we bring this back to do total solids, but we can't do that here. We have to use an oven to evaporate the water.
No, there's I only got it down to the 1.
Oh, okay.
I'm thinking mine would get a little good.
Oh yeah, very pale. No, mine's very strong. It's probably adding the starch, right? Yeah, adding the starch. This rock right there, it's actually right on the edge of this bucket here if we don't move this. Yep.
Ready? Gotcha.
Nice throw. Send him to the Yankees.
You want a second one?
I gotta watch right here. Yeah. Just tell me when to start. And I'll tell him when to grab it. Oh, you want to cut another one? You gotta cut that one. Where's the dies?
You all ready?
Yeah, I'm ready. Tell me when to start it. Well, drop it up a little bit above and tell me when it hits that spot. Try to hit. Do you see where the stream's coming through? Might be over a little bit further on the other side of the middle rock. You right there? Okay. Okay.
Ready?
Yeah.
Now.
Everyone's going in circles. I'm getting hungry. I think that duck's gonna become supper here. Either that or this crayfish.
I claim the water pit.
Yeah.
That one not get too hot in there for it.
Yep.
We've got 3 readings, right?
Yep. Yep. What we've just done there was we looked at the river to see how fast the river was flowing by taking a tennis ball, letting it travel to 50 feet, and recording how long it took to get there. Doing that 3 different times, taking an average, it gives us the average speed of the water. What we'll do next is we'll take the depth of the water, we'll take what's called a river profile. It'll tell us basically the volume of water, and then back in the classroom we'll be able to calculate how much water is actually flowing through this point right here every second, every minute, every day if we want to.
A brook is an ecosystem, and that means there are 2 parts that you have to be aware of. You have the biotic, the living component, and you have the abiotic, which is the non-living component. And many of the things that you've seen us testing here today, such as dissolved oxygen, nitrates, pH, all of these things are non-living properties of the brook, but they all have an impact on the living things. And so when you're doing a river study, you have to look at both factors. So there's 3 things you look for: physical factors, chemical, and biological. And so far we've gone over the chemical and the physical factors, and that would be, the physical would be like the speed of the water and the volume of the water. So we have one last thing that we have to look at, and that's the macroinvertebrates, which would be critters that are large enough to see with the naked eye. And people who have studied water quality, they have devised a method of identifying, or if you find certain types of critters that you can see with the naked eye, it tells you what the overall water quality is. So if you find certain critters, it gives you an indication that the water is bad or good, or if you don't find them, then that's an indication that there could be some pollution problems. So what we're going to be doing now is we'll be sampling the entire area here and trying to find as many different types of critters. Not all of them are important in regards to the classifying of whether the river is good or bad, but we're going to try to find as many as we can and document them. And on a chart that we have, we can circle the ones that are important. And by the end of the day, we'll get an indication of the quality of the water, just looking at the living things. And then we'll back it up with the chemical analysis once we find out what the chemical tests mean when we analyze that aspect of it. And usually they're within reason. If they aren't, then probably have to come back and just double check a few things. But overall, if they're found to be close to one another, then we know we'd had a good sampling on both parts, and we can then go and continue and look at ways to improve the water or leave it as it is if it's okay. Okay, what we're doing here is basically we're taking a look at any type of macroinvertebrate that we get out of the water, and again, certain species, certain types of critters are used to identify the quality of the water in which is flowing through a stream. And if you find these organisms, such as we found a stonefly in here, and our crayfish, here's your crayfish, you just circle it out here, and what you do is after you've identified all the critters that you found in your sample, you then go to this table. It's called a macroinvertebrate count, and as you can see here, there are different organisms that are either very sensitive to pollution, somewhat, or very tolerant. And each one of these groups of organisms has a certain value to it that you add up. And when you get done, as you add them up, we end up with a score that's numerical, and it tells us whether the water quality rating is either excellent, good, fair, or poor. And that's what we're doing right now. And then this information we compare with our chemical analysis, and we get a really good overall view as to what the health of the river is at this present time, at this time of year. And then we go and we use that for land management concerns, and use that as also to look at the ecology of running waters.
Great.
Wow.
We got a couple different ones in here. Is that the
That's your stonefly.
Okay,
Which
and
is
then
the two.
so we also have the hellgrammite.
Yep.
Over here.
Yep. And the reason. Yeah.
We had a mayfly in here too. I just saw it. Where'd it go? It was kind of clear.
He was a little guy.
The water's getting pretty warm.
Oh, there he goes.
Sowbug, SOWBU.
That guy there would be this guy right here. Number 9 there.
It's always important to make sure when you're looking at these identification
Sowbug.
keys that you look at the size of the little line on the sheet that tells you what size it is. Otherwise, you might look at something like this and say, that's a big bug.
Yeah.
But if you look at the line next to it, you realize that it's actually a pretty small macroinvertebrate.
Okay, I'm going to put him in. There he goes. Okay, well, today we've been here for the morning, and we've collected our biological, chemical, and physical characteristics of Beaver Brook. Unfortunately, we're not able to get all the students down here because of the situation with the mosquitoes, but from this point we'll take this information and apply it to studying what ecology is all about and how we can relate this experience that we had here to understand how land is managed to try to keep this type of environment healthy. So this year, from what we've had here, I hope you've been able to take something from seeing us do the work, but we will be planning to be back here next year, and we'll take it from there. Okay? Take care.